Hey, good people, welcome back. In the last video, we had left this question unanswered. We're going to use the technique we just learned in the last video, completing the square, to rewrite this quadratic in a better form. So we learned that if you take half of the x coefficient and square it and add it to this, it will turn this into a perfect square trinomial. So half of 16 is equal to 8 and 8 squared is equal to 64. So I just took this trinomial and I added 64 to it. Now you can't go ahead and just add any number you want to something without changing it. So I'm going to go ahead and subtract that 64, and there was also a plus 70 there. Now this part, the first three terms, are what is called the perfect square trinomial. So x squared plus 16x plus 64 is a perfect square trinomial. It can be factored as x plus 8 squared. And then this, we can just combine like terms. Negative 64 plus 70 is equal to positive 6. So we just changed this original quadratic, x squared plus 16x plus 70, into the quantity x plus 8 squared plus 6. This is a much better form, and we're going to learn in this video today why that is. It's in what's called vertex form, and we're going to be graphing some of these today. This is our first video in which we're graphing these quadratic equations. They're called parabolas. So in this video, you will learn how to apply the technique called completing the square in order to find the vertex form equation of a parabola. And here is some new vocab. A quadratic function is a function that can be written in the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. An example is over here to the right. This is a quadratic function in standard form. And it's quadratic mostly just because of this degree. The degree of the polynomial is 2. Its highest exponent on an x is 2, so that's what makes it quadratic. And quadratics have a shape called a parabola. Just like a linear equation is shaped like a straight line, a quadratic function is shaped like a parabola, which is this U-shaped curve right here. The shape of a graph of a quadratic function is a parabola. And these U-shaped parabolas, they could be upside down as well. The vertex of a parabola is the highest or lowest point on the parabola. If it's a right side up parabola like this, its vertex is a minimum, and if it's a inverted parabola like this, its vertex is what's called a maximum. So why do we learn this? Well, it just so turns out that an equation in physics for the height of an object according to the time in which it falls is given by this equation here, negative 1/2 times the acceleration due to gravity multiplied by time squared plus the initial velocity multiplied by time plus the initial height. And what we have right here is a quadratic equation. If you think of t as being our x, we have x squared plus something x plus some constant, and this is a quadratic equation. So the reason we learn about this is because a very real life thing is modeled by a quadratic, and that's the motion of objects falling to Earth due to gravity. So let's go back to lines for a second. When we graphed lines, we had a few equations that we learned. We learned the slope-intercept form, which you guys were probably most comfortable with, the standard form, and then we also did some point-slope form. When we learn quadratics, the one that's probably the most useful is called vertex form. The slope-intercept form is useful because it gave us the slope and the y-intercept. And the vertex form is useful for us because it has the vertex, the coordinates of the vertex, built into the equation for us. So here are a couple lines that I graphed, and I wrote their equations into three forms. This is probably the one we would like to work with, even though they're all equivalent. Here's another line graphed, and it's three equations. Another line graphed for you. Now, quadratic functions. Here are a couple examples, and I wrote their equations in both vertex form and standard form. There is a connection between the vertex and the vertex form equation. You'll notice here the coordinates of this vertex are 2, 1, and you see a 2 and a 1 right here. If you'll notice here, the coordinates of this vertex are -3, 5, and you'll see a 3 and a 5 right here. So the vertex form equation has the vertex of the parabola embedded in it. Here's another example. The vertex here is 2, -5, and you can see a 2 and a -5 there. Another example, this vertex is 0, 0. You see a 0 and a 0 there. So the vertex form of a parabola is given by y is equal to the quantity x minus h squared plus k, where h, k is the coordinates of the vertex. Notice that in the formula there's a minus h, and just like what we did back when we did point slope form, is whenever there's a minus, we give the opposite of that coordinate. And here's an example of that. This is a parabola that's graphed. Notice it's upside down and has a negative in the front, and that's actually why it's upside down. But we're going to just focus on the vertex. This should be the vertex, but the formula has a negative sign here. Right up here, there's a negative sign. So a way I could write this is instead of x plus 3, I could write x minus -3, because subtracting a negative is the same as adding a positive. Now this is in the exact form that you see up here, and I can identify that the vertex is -3, +5. That's our vertex. And you can verify that by looking at the graph here. It does have a vertex at -3, +5. All right, let's do another example. This one is not written in vertex form. I can't just say that the vertex is at -6, 4. It doesn't work like that at all. This is in standard form, and that's not really good. We want to get it in vertex form so we'll know where to plot this vertex. So the first thing you really want to do is focus on this x coefficient. We're going to use that process of completing the square that we did in the do now. We're going to cut that in half, and then we're going to square that result. So half of -6 is equal to -3, and -3 squared, or multiplied by itself, is equal to 9. So we're actually going to add 9 right here. And then since we added 9, we actually changed the problem. So to account for that, we're going to take away 9. So I added 9, then I took away 9, so there's a net change of 0, and you're allowed to do that. What we just created is a little perfect square trinomial right here. So that thing right there is the perfect square trinomial that we're now going to factor like this. If you remember, you take the square root of the first term, the square root of the third term, separate it with whatever sign's in the middle there. So I just factored that perfect square trinomial, and I took that -9 and 4 and I combined them, and that's where my -5 came from. So this is actually the equation in vertex form. It has the vertex right here. And I'm just going to go ahead and plot that point 3, -5. I'm going to plot that on my coordinate grid. 3, -5. And since there is no negative in the front of this equation, this is going to be a right side up parabola. There we go. And I graphed this quadratic equation by identifying where the vertex was, and then I just drew that U shape. We'll get into more detail about exactly what points to plot when you're plotting these. We usually look for where it crosses the y-axis, or the x-axis rather. These points are called the zeros, but we'll do some more involved problems later on in this unit. But for now, we're just identifying the vertex and we're sketching a rough picture of the graph. Let's do another example. By the way, that's the same function. I just used a program to graph it. So I guess my graph was a little bit off, but it was the vertex was correct. All right, so let's do another problem. We need to plot the vertex. This is not in vertex form. So we begin by focusing on that middle x term. We cut that number in half. So we take half of that number, and then we take that result and square it, and 1 squared is 1. So we're going to be adding 1 and subtracting 1, because you can't just go ahead and add 1 to something without changing. So I added 1, then I subtracted 1 to undo that addition of 1, and now we created something called a perfect square trinomial, this part. So that's a perfect square trinomial, and we can factor that pretty easily. That would be x plus 1 squared. And now we have negative 1 minus 3, that's negative 4. All right. So we have to identify the coordinates of the vertex. They would be right here and right here. Now, the way the formula is written, it has a minus h. So you have to understand that even though it says x plus 1, you can interpret that as x minus negative 1 to help you better use this formula up here that has a minus in it. So now the coordinates of the vertex are really negative 1 and negative 4. Negative 1 and negative 4. I'm going to plot that on my coordinate plane, negative 1 comma negative 4, and then I'm going to just draw a rough sketch of a parabola. All right, and there's my final graphed form. I used a program to graph it. All right, we're going to do one more problem. I want you to graph this parabola. Y is equal to x squared plus 6x plus 1. Is this a perfect square trinomial? No. So we're going to turn it into one by cutting this in half and squaring it and adding it to both sides. Or squaring it and adding it and subtracting it. So I have to add 9 and subtract 9. And then I created this part, which is the perfect square trinomial. And then I factor that using the technique that we learned in our last week, factoring special case perfect square trinomials. So it would be x plus 3 squared. And negative 9 plus 1 is negative 8. So now, if you'd like, you can rewrite that x plus 3 as x minus a negative 3 to help you better identify the vertex. The vertex of this parabola is negative 3, comma, negative 8. And if you were going to sketch a rough picture of that, you would make a point at negative 3, comma, negative 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and draw a rough sketch of that graph. So this is our first introductory lesson into graphing parabolas. We're focusing on this form of the equation, which is called the vertex form. And please try the assignment that I uploaded on Google Classroom on Monday afternoon. There's a few questions that ask you to just simply add a number to change something into a perfect square trinomial. And then there's a few that ask you to rewrite the equation in vertex form and identify the vertex. Thank you for watching, and I look forward to seeing you this afternoon in our video meeting at 2 p.m.